Okay, remember the isosceles triangle theorem? Says if you have an isosceles triangle, then the angles opposite those sides are congruent, even if they're not marked. Remember, the base angles are congruent. And the converse of that, the converse of the isosceles triangle theorem, says if you know you have two angles that are congruent in a triangle, then the sides opposite those angles are going to be congruent. But the Monday Madness is more about the isosceles triangle theorem. It doesn't really do the converse. And what all the angles in a triangle add up to? 180. All right, so today we're working on 4-8 triangles and coordinate proofs. So what we're going to be doing is placing triangles on the coordinate plane, and that's by placing it on the XY axis. So what we want to do is think about the parts of the triangle that would be important, okay? So we are going to use the origin as a vertex or the center of the triangle, like the midpoint of the base or something like that. But a vertex is good. Then place at least one side of the triangle on the axis. Well, the only way you could put two sides on the two axes is if it's a right triangle, which you will be doing. You want to keep your triangle in the first quadrant if possible. So if you're going to sketch your picture, just drawing the X and Y, just drawing the first quadrant is fine. And you want to use coordinates that make computations as simple as possible, okay? So let me just kind of give you a quick example. Say I want to graph a isosceles triangle. Okay, so here's my X and my Y. And I want, so I'm going to make my vertex, one of my vertices, 0, 0. And then I have another vertex, and then the third vertex is going to be my vertex angle, and it's going to be right above the halfway mark. So if I were to make this coordinate A, like the base is A. Wait, I have people in the waiting room. If I make the base A long, so then this would be A, comma, 0. Okay, and then since the vertex angle is going to be above my halfway mark, this half mark here would be half A. Okay, so this coordinate would be 1/2 A, comma, and then it didn't matter how tall it is, you would call that B. And so then we would have an isosceles triangle. So another way to do it is to draw the, put the middle of the triangle on the origin. So for example, if I had, draw this out a little longer, this is my halfway mark on the, so I could draw my vertex up here. Say my vertex is B long, so that coordinate would be 0, B. Then if I put my one coordinate here at A, 0, my other one would be at negative A, 0. And then this could be an isosceles triangle. But how long is the base? That would be 2A. 2 times A is how long the base is. Okay, so this is just an example, or these are the steps that you take when you want to place a triangle on the coordinate plane. Okay, so now let's position and label a triangle. This is an example out of the book, and I'm just going to kind of read over it with you. So we want to position and label a right triangle MNP on the coordinate plane so that leg MN is A units long and leg NP is B units long. So the lengths of the sides that are along the axis will be easy to determine than the lengths of sides that are not along the axis. So if you place the right triangle, the right angle, wait, I'm sorry. Since this is a right triangle, the two sides can be located on an axis, so that's good. So placing the right angle in at the origin will allow the two legs to be along the x and y axis. Position the triangle in the first quadrant. Since M is on the y-axis and its x-coordinate is 0, its y-coordinate is a because the length is a units long. Since B is on the x-axis, P is on the x-axis, its y-coordinate is 0. So its x-coordinate is B, and the point is B, 0. Okay, everybody, do you understand that? All right, let's do one ourselves. So we're going to position and label an isosceles triangle, JKL, on the coordinate plane so that the base, JL, is A units long. The vertex, K, is on the y-axis, and the height of the triangle is B units. So it's sort of like one of the examples I gave you. Okay, so we want to position and label the isosceles triangle JKL on the coordinate plane so its base, JL, is A units long. The vertex, K, is on the y-axis, so this is going to be our K. And the height of the triangle is B units long, so this is B units long. So the height goes from the top to the base. All right, so that would be at 0 for our x coordinate and B for our y. Okay, so now we want our JL, and we want it to be A units long. So we're going to have to make this at 1/2 A, 0. And this one at -1/2 A, 0. And so there we have this base is going to be A units long. Tomorrow, we're going to start doing coordinate proofs. And so you're going to have to place the figure on the graph and then do a coordinate proof. So this is like doing a formula using letters based on what you have. So say I wanted to prove that triangle JKL is isosceles. I would have to do the distance formula on JK and KL to prove that they're the same. And so I'm using letters. So JK, I'm going to use the distance formula. I'm going to subtract my x's and square it, then subtract my y's, then square that. So at J, my x is -1/2 A, and my K x value is 0. And then I have 0 minus B. So here when I do the math, I have -1/2 A squared plus -B squared. So this is 1/4 A squared plus B squared, and of course it's still under the radical. And that's as far as I can go. So this is the length of JK. So as long as KL is the same length, it doesn't matter that I don't have a number there, okay? So let's do the distance between J and L. So we'll have our x's subtracted and squared, and we'll have our y's subtracted and squared. So not JL, we're doing KL, aren't we? Okay, so K, 0 minus 1/2 A, and our y's are B minus 0. So I have -1/2 A squared plus B squared equals 1/4 a squared plus b squared, and of course this stays underneath the radical. All right, so since JK and KL are equal, I have an isosceles triangle. And this generalizes it, okay? We're going to do these tomorrow. Today, we're just going to be placing these on the coordinate grid so that you are able to do that so you can do the proofs. We're going to do the formulas with the letters in them.